going? Nice to see you all. I gotta tell you, I've been here since 9 a.m. As you may notice, there are no windows in here. So in my mind, I'm just assuming it's a beautiful day out there. This is pretty much right? Good, thanks. So welcome to Cool Jobs. If you've never been here before, it's a really interesting session. It's a time where we show you occupations that you might not have thought of that use the tools and method of science to solve a problem or perhaps unravel a mystery. The world is full of mysteries, guys. For example, what is the origin of black holes? Why did the dinosaurs go extinct? How do tornadoes form and appear and disappear? Why do we why do we park in driveways and drive on parkways? Have you thought about this? These are the things that keep scientists up at night. So we're going to show you some really kind of interesting jobs, and hopefully the idea is, especially if you're one of our younger members of the audience, that you think, wow, I kind of like science, but I hadn't considered that as a possible future job. And so hopefully we'll inspire you to look a little further and open up the possibilities for you in the world of science. And our very first presenter today is all about unraveling mysteries. In fact, she unravels mysteries for detectives using science. So please welcome our very first presenter, Professor of Chemistry, Dr. Raychelle Burks.
Hey everybody. I have a confession. I am a giant nerd. That's good. I've been a nerd my whole life. I'm the only nerd in my family, in fact. Everybody else in my family is much cooler and sporty and coordinated. And I am also a big reader. When I was little, my parents got an encyclopedic kit for home. And I read the entire thing from, of course, in order, because if you don't read them in order, that's just wacky. And I was such a big reader that I actually won a bookworm award that I'm very proud of, because I still have it. Thank you. And my second confession of the day would be that I have a really wacky obsession. Not chocolate, although that is delicious. When I was a little kid, so about your age, I was obsessed with rules and with the law. I couldn't understand why I couldn't keep my room as dirty as I wanted. Like, who made that arbitrary rule? Why I couldn't cross the street wherever I wanted. So I used to go to the library on Saturdays and read law books and write up little legal briefs. And my parents would actually read them. So thank you, Mom and Dad. And so, of course, with my love of reading and my love of laws and rules, what do you think I wanted to be when I grew up? A lawyer. I was convinced I was going to be a lawyer. I had my little lawyer briefcase, and I would go to school, and I was going to be a lawyer. And then, in my 8th grade year, my school went on a trip to Washington, D.C. So you can imagine, as a kid who wanted to be a lawyer, this is like the trip of a lifetime, right? It all went horribly wrong. And it went horribly wrong because I got to meet some FBI scientists. And then everything changed. Up until that point, I never wanted to be a scientist. I didn't find scientists or science remotely interesting. And maybe that's because I never saw any scientists that looked like me. Maybe that's because, to me, science was literally out of this world. I did not see how science was useful or practical. I didn't connect with it. But when I was in DC in the 8th grade year, I got to meet with these FBI folks, and my whole class did. And they were using science in a really applied, practical way. They were solving crimes. They were freeing people that had been wrongly convicted. They were convicting bad people. It seemed really useful and practical, and I saw people that looked like me doing really cool stuff. And ever since then, I switched from an obsession with rules to an obsession with forensic science, which I had never heard of before I went on this trip. So totally changed everything that I was doing. And I started gobbling that up. And I started gobbling up information about chemistry. So I went on to college, and I got a bachelor's of science in chemistry, a master's in forensic science, a PhD in chemistry. In fact, here's a picture of me and my dad. You know, when you get a PhD in chemistry, They give you a cape, actually. It's really cool. They call it a hood, but we all know it's actually a cape. So there's me and my dad, and I worked in a crime lab for a while, and now I am a chemistry professor at St. Edward's University in Austin, Texas. Go Goats. And what do I do now? Well, I get to teach great young minds, but I also get to help make methods and techniques to discover what chemicals are at crime scenes. When you're at a crime scene, you have a lot of unknown stuff. What is this red thing? What is that white thing? You have no idea what it is. So I actually work on systems to help discover what these mystery chemicals are. And hey, what are you doing? Oh, great. So, this New York crime problem is really out of control. So we were gonna actually have a little bit of fun, little Cookie Monster action. We were gonna bake some cookies, but unfortunately now, what do you need to bake cookies? Well, you need a lot of stuff, but you need sugar, you need just a pinch of salt, right? Just a little bit, and you need some baking soda, okay? And so unfortunately now, we have 3 mysterious white substances in 3 jars. And there were labels on them, but she moved them around. Does anyone remember which one went which? Because I actually don't. I don't quite remember. But we need to be sure, right? Do you want to add a cup of salt to chocolate chip cookies? No. You want to add maybe 1/4 of a teaspoon and then add a cup of sugar. So we're going to need to get to the bottom of this mystery. And for that, we're going to use just a little bit of chemistry, because what I love about chemistry is if you just know a little bit, you don't need to know everything. And you don't need to memorize periodic table. We put it on a table for a reason. If you just know a little bit about chemistry, you can solve a huge number of mysteries. So I just need a couple of volunteers. Are these my assistant sleuths? Awesome. I'm going to have you can you walk straight towards me? Okay. And then we better be super safe. We got awesome gear. Okay. I'll have you put those on. And you're going to follow me right around here. Okay. So, I'm going to assign each one of you a mystery jar. Can you have this one? Can you be in control of that one? And I'm going to give you this one. Can you be in control of this one? And I'm going to give you this one. Now, audience, if this had happened to you at home, a thief broke in your house and stole all your food labels, which would be bizarre, how would you figure out which one, salt, sugar? Taste it! Who would vote for tasting? Okay, first rule of Chemistry Club is we don't ever taste anything. Because a lot of bad things are actually very similar in appearance, and if you taste them, no, that's not good. We won't get into why, but it's not good. What would be another thing you'd want to do? Feel it? Okay. Again, another rule of Chemistry Club, we don't want to touch it because it could be bad for us, right? Okay. Ooh, we are going to test it because we don't want to smell it either. I heard someone say smell. We don't want to smell it because you could inhale it, and also not good, right? If it's dangerous, that's not good. So this is a future chemist right here. I'm dubbing her, I'm keeping her already for our field. We're going to test it, and you guys are going to help me do that. So what I need you to do, I'm going to give you your scientific implements. Okay? And can you put 1 spoonful of your mystery stuff in a jar for me, please? Perfect. I love this guy. He's like, I'm measuring this, whatever. But you did touch it, so that's okay. That's okay. We're going to let it slide this time. Can I have this one? Awesome. Awesome. Now, you guys look like you are like fun scientists at home, so you've probably done this. This is just vinegar. Okay? So we are going to start adding it to everything. Because why? If one of these is baking soda, what's going to happen? Boom! Right? Ooh, that's pretty boring. Okay, not fun chemistry so far. Also boring, not gonna lie. Aha! All right, so we've got 1/3 of our mystery solved. You have the baking soda. Now you two, though, we gotta do a little bit more work. Are you up for it? Yeah. Okay, so here's what I'm gonna need you to do. I need another spoonful, one in each. Okay. All right, can I have those? Awesome, thank you very much. Now, here's what I'm gonna do. I'm gonna add a little bit of water. So I'm gonna make, well, I don't know, I'm gonna make, one of these is gonna be salt water and one of them is gonna be sugar water, also known as Kool-Aid when I was little. And I'm gonna put it on a hot plate. And let's step back over here because we wanna be super safe with the science, right? So here's what I know is gonna happen. Salt and sugar are both molecules, but their atoms are attached very differently, and they have very different properties. And salt water, we have a lot of salt water on the earth, right, you guys? Like, it's everywhere. Now, sometimes when you want to actually drink salt water, you got to get, like, all the salt out of it, right? So how do we do that? Well, it's easy. Salt has a really, really high melting point, really high boiling point. Water is really low in comparison, so we can boil off the water, we capture it as steam, and all that's left behind is big piles of solid salt. It works great. Now, what happens when we boil sugar water? Well, sugar is a very different molecule. It actually can burn and melt at a fairly low temperature. Have you guys ever eaten burnt sugar? How about caramel? You've never had caramel?
Wait,
Who?
caramel like the cake?
Caramel like the sauce, or caramel ice cream, or caramel. Anyone have caramel? Okay. Caramel is burnt sugar. Sugar itself, the other reason why smelling wouldn't have worked is sugar doesn't really have a scent, actually. But when you burn sugar, don't you smell, have you ever made caramel and you smell that delicious smell and it starts to turn golden brown, everything is just wonderful? Well, when it starts to break down, it makes compounds that are stinky, and stinky in a good way. So you guys stay here, I'm gonna walk over here. Now, I don't know if you can see this, you guys, but how this one's really clear, right, and looks pretty clear, but this one still looks pretty white, like lots of kind of milky almost. Well, I kind of think that this one is the salt. Even though we know that salt is soluble in water, once all of the water starts to evaporate, the salt stays behind, and so to us, it's gonna look really kind of cloudy and weird. But this one is not cloudy at all. In fact, to me, it looks like it's getting a bit thicker. Like, have you guys ever had pancake syrup?
Yeah.
Pancake syrup, maple syrup, so that kind of another sugary, watery substance. And so if you guys would walk way back here, because we want to be super safe, you get a better look at those two containers, right? How one of them is really, really white. You see all that white stuff on the side? That is actually salt. So I'm ready to call a mystery. Now, the other thing is you see how the other container, it's starting to go like a pale yellow. And it's going to take a couple more minutes. But what's going to happen is it is going to turn brown, that nice color of caramel. Okay? And so I'm ready to call this mystery that we already know that you had the baking soda, right? Okay? And I'm ready to call it right now as this one's going to be the one that had salt, and this one, ooh, and I know this one's the one that has caramel, because if you are sitting or standing pretty close by, you're going to start to get that delicious caramel smell. And so again, with just household chemicals and a little bit of testing, we were able to solve this mystery. Thank you guys so much. Okay, and I'll take these. Okay. Thank you guys very, very much. The reason why I love chemistry is because it doesn't take that much information to sort out the mystery, to figure out what's going on. And I'm going to actually turn this down, but I'm going to let it actually sit so you can see that brown color develop a bit. The reason why I love chemistry and I love my job is that a little bit of knowledge about chemical and physical properties can help us actually solve big problems. And it can also help us prevent crime, and that's another thing. So the other thing I work on is systems to actually detect things and to prevent things from happening. And chemistry allows us to do that. We can figure out all kinds of stuff by just doing some testing and experimentation. Now, we can do crimes, but if you apply the same type of thinking, you can get to the bottom of another type of mystery. So, anybody here a Star Wars fan? Okay. Hey. Hey. Now, I'm old, so I remember seeing Empire Strikes Back in the theater, but I'm not so old where I start Star Wars. But does everyone remember or has seen recently the Death Star? Okay. Starbase Killer is the new version, right, in The Force Awakens. So we have the Death Star. How does the Death Star work? It supposedly is a laser-based weapon. So it has 8 laser beams, and they're all going to converge at a point and make one big super laser beam, and it does what? Destroys planets, right? Ships, blows stuff up. That's the fun part of chemistry, too. Chemistry, we have fire and we have explosions, right? So that's going to be the fun part, right? Now, as a scientist and as someone who tries to unravel mysteries and get to the bottom of things, I look at this and I go, I don't think that it could work, okay? And I don't think it could work for the simple fact of, I don't think lasers work that way, but we need to test it, right? We need to get to the bottom of it. So I'm gonna need 3 more people who want to help me test out if the Death Star would work. So come on up. I'm gonna have you stop right here. Okay, and can you guys go like maybe right here? Oh, so perfect. Look at this shirt. I love it to death. Okay. So I'm gonna give you guys each part of the Death Star, okay? And you're gonna need to fire it for me. Can you do that? Okay. And by the way, do you see the caramel? Okay, looks great. So part of the Death Star, and by part of the Death Star, I mean a laser pointer. Okay, I'm gonna give you that. Now please, for safety, don't point it at anyone's face. Just, yeah, you can point it up here and maybe at your cat later. They seem to love it. Okay, I'll give you one of these. Okay, give you one of these. Now let's do a test. You see that skull up there? Okay. Now that's not a real person, so you can point it at them. So it'll be okay. Everybody try to aim your beam at an eye socket, the right eye socket if you can. Okay. So we need to, I see it on the black curtain. Let's lower it down, maybe right. We want to get right here. Okay. I'll have you point yours. See how yours is right over here? Let's drop it down. Okay, so I see 3 dots, right? Now, everybody's pointing at the same point, okay? Do you think we're gonna see 1 beam or 3? 1. 1? Okay, let's see if that's true. I see 2, I see 3, okay? What I don't see is 1 super death beam. Even here, I don't see 1 super death beam, okay? So with a simple bit of, thank you guys for helping me make the Death Star on stage. I appreciate that. Can I have that? Don't worry, we'll get you one later. Okay, thank you guys. Same thing, the reason why, thank you guys, I appreciate it. Simple bit of technology and a little bit of science know-how, and you can get to the bottom of a mystery, whether it's fictional, like could they make a Death Star, or whether it's real life and practical, like what is that chemical at a crime scene. And the fact that you can actually just know a little bit of information and solve a world of mysteries is why I think being a chemist is a cool job. Thank you guys.
All right, so I want you to imagine this. We're thinking of going to Mars. You're familiar with this? Yeah, so we're thinking of going to Mars. And imagine, when you go on vacation, and then you get to vacation, and then you realize, like, oh, we left something. We left the sunscreen back home. And then you got to go to Walmart and pick up some new sunscreen. So imagine going to Mars. You go to set up your new habitat, and you realize you left the wrench back home. Well, now you got a 9-month journey back, and that's not going to work. And there are no Walmarts on Mars. We hear there might be Starbucks, but there are no Walmarts on Mars. So what do? Well, then you call NASA systems engineer. And NASA systems engineers, boy, they are some really, really great problem solvers. And it turns out we have one here today. So for our next guest, please welcome NASA systems engineer Erick Ordoñez.
Wow, how y'all doing? Lots of beautiful people, man. So, my name's Erick Ordoñez. I'm from Huntsville, Alabama at NASA Marshall Space Flight Center. Real quick, let me start something. All right, well, that gets going. I want to ask everyone a question real quick. Who here knows what a system engineer is? You know one, okay. What's a system engineer? Okay. All right. That's a good shot, good answer. What about an engineer? Who here knows what an engineer is? Yeah. So an engineer, don't feel bad, guys. I didn't know what an engineer was until a month before graduating high school. And I graduated with 2 engineering degrees from the university. So it's okay. I grew up in a town called Madison, Alabama, outside of Huntsville. I have a brother, a mother, my mom, single parent. Where I grew up, I was the only Hispanic kid in my school. And I was your typical kid. Football, baseball, basketball, track. I was captain of all these teams in high school. Never thought about science. So my senior year in high school, I'm in an environmental science class. And with environmental science, that's the class everyone takes, because you know what? That's an easy A class. So you want to get that GPA higher, you're like, environmental science, I'm there. So going to class, there's 70 of us in this class. And so they're trying to downgrade the size. And here comes a chemistry 2 teacher, Miss Pickens, and I love her to death. She looks at me and she says, "You come with me." I'm like, really? Out of 70 people here, you're gonna pick me? What? Am I the only dark spot in the room? What's going on? No. So I tell you what, that changed my life. That day she picked me to come to chemistry 2. Chemistry is more than just elements and, mixing chemicals together. It's actually playing with science. So because of her, I got to actually do real science. I joined a team called Science Olympiad. Anyone here know what Science Olympiad is? It's a team that you can do in the high schools. Sign up for it. You get to really build things. We got to build rockets. We got to build these crazy things, steel bridges, popsicle stick bridges. And one of the things that I was left was a new design called a water strooter. It's like a little jet ski on water, but you had to make one yourself. And you got to use household products. I used a Thousand Island salad dressing bottle. It was great. So I designed this thing, never done it before, and we went to regionals and I won. Went to state, I won. And that changed my life. That's when I knew I wanted to do something different. And that's when I asked my teacher what I want to be. She says, an engineer, and so forth. I went to college. Got to college, goal was to play college football. Got to do it in New Mexico. And first thing coach says on the first day of practice, "What's your major?" And I said, "Engineering, sir." He's like, "What?" "Engineering." "No, you can't do engineering. You'll never have time to play football. Football's serious in college. It is in high school. It's serious." So, no one's going to tell me what I can do. I'm here to do engineering. That's what I'm going to do. So, long story short, graduated mechanical and an aerospace engineering degree. Loved it. First job out of college, I worked at NASA Johnson Space Center in Houston, Texas as a test engineer. And so one of the test engineers I did was hypervelocity impact testing. And what is that? So we design shields for any spacecraft that goes into space. Real quick, can I have you come up real quick for me? Here, catch that. Oh. So we build shields for these tests for our space flight articles. We build shields for our space shuttles, International Space Station, and so forth. Now I need you to do a quick stand up. So this is just junk. We've been in space since the 60s, and we got junk floating all around in space right now. And this little thing is just a small example. I want you to hit this. Okay, let's pretend you hit that. So we're going to pretend boom, it hit, fell. What happened? Nothing, right? So what if we're in our space shuttle, we're floating around, we're in the International Space Station, we're floating around the Earth. Can you please cue the video? The same piece of metal. That happens. 17,000 miles an hour. First thing you do when you get to Houston and you're a test engineer, they tell you test for the safety of the astronauts. Your key priority is the safety of the crew before anything else, before mission and so forth. So the entry hole, exit hole. You hit this thing here, nothing. That same plastic ball in space, you destroy the International Space Station the size of a football field. So, did that for 5 years, got to travel. Enjoyed that. It was a great experience. Got to meet great astronauts. Got to see, inspect the space shuttles. Who here has been to the Intrepid here? Got to see the Enterprise. That's really cool, huh? I got to actually work on some of the space shuttles that are in LA, the Discovery and Endeavour. That's in Florida. So I actually got to work on those space shuttles and inspect them. It was a really great experience. Changed jobs. I wanted more than just to be an individual test engineer. My next goal I wanted to be was an overall materials. I wanted to be more than just a test engineer. So I became a materials engineer. Materials engineer, now I'm not just responsible for testing one side of the project. Now I got to test other materials. I got to burn things, bend things, break things. Anything we went to space, we tested. We broke it, tested, make sure it was safe for the astronauts. The clothes the astronauts wear in space. We actually make those ourselves in-house because flammability. We gotta make sure it's safe for the astronauts. So we make all those processes. So I did that for 2 years, loved it, got to work on some cool missions. Then I moved on to what I do now is a system engineer. So as a system engineer, our job is to communicate. As I was a test engineer, then I was a materials engineer, now a system engineer. An example of that. Right now, I'm gonna use you, sir, stand up right here in the corner. You are my mechanical engineer, okay? So you come to me, you're given to me as from your boss, and your boss says, this is your mechanical guy. I say, great, nice to meet you, you're on my team. We go have coffee, we have a good time. And then I have you over here. Can you stand up? I want you to say hi to him. Say hi. You are my electrical engineer. And I tell you, okay, I need you to talk to the mechanical. Y'all gonna be best buddies because you're gonna design something for my mission. And you say, cool. So y'all hand off, y'all design, y'all talk together, communicate. Then you come back to me and you say, Eric, this is what we got. This is your power. This is your mechanical structure. So then, I think you can sit down, thank you so much. So then I take that and I go to another other person in the corner. Can you stand up, ma'am? Stand up. Yeah, you go ahead and stand up. You're my design engineer, so you're now gonna take the CAD model of what they give you and put it all together. And then you come up and you say, Eric, here's your piece. And I said, great, it's amazing, it's awesome. You can sit down, thank you so much. And then I go to my project manager and HUD up and I say, okay, $10 million, this is what you get. And of course the project says, 10 million? You were only given 500,000. I said, yeah, but what had happened was, and the rest is history. We go back and forth. I'm always communicating to the team. So think of me as like the team captain of a football team. I'm the one responsible for the team, making sure the players are in the right spot, everything's working together, everything's flowing together, and we're communicating back and forth from the project. So the project I'm working now, in-space manufacturing. I am the lead system engineer for in-space manufacturing. And so, real quick, what do you think this is? Come on, stand up right here. So, take that, show everyone, wave it up in the air. So, we have a 3D printer on the space station right now. Pass it around. And so, one of the things is, we asked the astronauts, what are some things that you need? And we had an astronaut on board, and Commander Buzz comes up and tells me, he says, you know what? It's really dry, and I got this itch in my back sometimes. And it's like, okay, could you design a back scratcher? And let me tell you, you see that back, we went through like a dozen iterations because you have to go through this whole safety, that whole process, talking to here. We did that like a dozen times. So I asked him, well, why do you need back? He says, well, you know, I don't really want to ask my partner over to scratch my back. And we got some important equipment here. It just doesn't feel right going, ah. And so we asked, okay, what do you want the back scratcher to be like? Boom, and we created a back scratcher. So a lot of other different units are being done. Here's another piece. Why don't you come over here? Come. Take that. What do you think? Show it for everyone. What do you think that is? Yes. A wrench. Close. We'll get to a wrench. That's actually a oxygen sensor holder. We basically attach that to the environmental control life support system. So currently, who here likes to drink urine or pee? I've had some. Tell you what, it's not bad actually. It wasn't bad. Sweat, urine. Well, we've developed a way that we can take your sweat and your pee and turn it into drinkable water and create oxygen from it. So the ECLIS system, the Environmental Control Life Support System, we use that. We developed that. Currently, they would take a sensor, put it in, and it would tell us how much oxygen concentration it would have. Well, the astronauts holding this for 20 minutes, they got other things to do. So we developed this holder for it. What's the next thing an astronaut might need that we're currently printing right now? A spoon. So the spoon is another object here. Let's have it on this. Why don't you come over here, take a look at the spoon. So when an astronaut goes into space, he's given many things, but he's given one of those, and it always stays in his pocket. He's only given one. He's told, don't lose it, because you don't get another one. So if they lose their spoon or their spoon breaks, guess what they use? Their fingers. You know, it's not really fun eating banana pudding like this, I promise. So 3D printing, we're using it right now in space. There's a lot of things. These things we're showing are very good as samples. Here's another tool, our wrench. And one of the things we're trying to take it, pass it back, show it around. One of the things we're trying to do is we're trying to show that we don't have to take things from the ground anymore. We don't have to take a dozen wrenches. We don't have to take a dozen spoons. If we can just take the product that makes it and actually make it in space, save the weight on the ground, because the most important part of, manufacturing thing is the weight it costs. It costs right now currently, I think it's $100,000 per pound that we send up in space. Okay, so if you look at me right now, there's a reason why I couldn't be an astronaut. So, the future, what is 3D printing going to be in the future? Where are we going with this? What do you think this is? Let me get you over here. Come on. Take that, pass it around. What do you think that is? Real quick. Yeah, it's a jar of Mars simulant. So Mars simulant is the dirt from Mars, but it's not from Mars, it's from a volcano in Arizona that has the same properties of what the Mars dirt would be when we go there. So we ask, well, what do you need that for? Well, as Science Bob says, you go on a trip, you forget something, you gotta go to Walmart to go pick up a toothbrush. Well, wouldn't it be cool if there was Walmarts in space and we could build them up? Can you clear the next video? See that building on the left? That's our Walmart in the future, I think. So our goal is to be able to 3D print houses and huts for astronauts, and to be able to do it in 24 hours. So if we could build your house in 24 hours so you can live in, wouldn't that be great? So we're working towards that. And so that Mars simulant we know there's water on Mars. We know that if we have enough dirt, the additives, we can process this. Currently, we're working with the Army and other departments here in the US to be able to create this process. So that is the future, 3D printing. We do in-space manufacturing, where it's in space, terrestrial, the moon, the Mars, go to asteroid. We want to be able to do this for our astronauts. So in closing, with this, there's always goals. There's always things we're trying to get better on. And I live by this. I told you as a kid, I never thought I was going to be an engineer. I always thought I was going to be something else. And you got a lot of people with a lot of cool jobs. And you look at your jobs, oh, it's okay. But you realize you really do have a cool job when you see all this. And I live by this thing. I want to leave you with these 3 things, kids. I mean, no matter what, I call it the 3 Bs. You want to be successful? Listen to these 3 Bs. Number 1, be respectful. Always be respectful. Number 2, be yourself. All right? You want to always be yourself. And the third one, and this is the one that I really, really harp on, is be tomorrow. And I say be tomorrow real seriously because you always have to have goals. It's like I can tell you right now, my be tomorrow is that I believe someday I will be a NASA administrator for NASA here in the U.S. All right, guys, thank you so much for your time. You're amazing. Enjoy the day, and we'll see you real soon.
All right. Awesome. NASA engineer right here on this stage. Listen, we also want to, we got our 3D printer going. We wanted to thank the Staten Island Makerspace. They donated or loaned us their printer for this little demo. They will be around after the show if you want to learn a little bit more about how 3D printers work and what do they do. And also, if you haven't gotten a chance to check out some of the things that Eric handed out, he will also be around after the show. We'll tell you all about the fun stuff going on after the show. Whoa, look at all this. All right, so maybe we've kind of covered the future, but we know that a lot of scientists are interested in our past, way back, ancient civilizations, uncovering our very beginnings, uncovering things like mummies, and actually, instead of going into space, digging into the ground. And so we have a presenter here, and that is her cool job. So to tell us a little bit more about what she does, please welcome forensic anthropologist Angelique Corthals.
So thank you, and thank you very much for everybody for inviting me here. It's really exciting, and just by these few words, you can tell already that my accent is not from around here, right? I was actually born in Belgium, which is very famous for the waffles, and the parents probably for the beer, right? But right away, I was taken away from Belgium, and I was actually raised in Central Africa and South Africa, so I got to travel the world a lot and experience a whole lot of things. And as a kid, I was really an outdoorsy kid. I just couldn't stand in place. I had to go out and roam the world, and I would do that with my dog, and we would go into the wood and have those magnificent adventures where we would try to solve mysteries. We would go and see a bizarre-looking tree, and that tree had to have been planted by a pirate or something. And it had to have been like a treasure at the bottom of that tree. So, of course, we had to dig. And I had a dog with me, so it was very easy to dig. Unfortunately, I repeated that experiment in my mother's garden, so she's not very pleased about that. But she already understood that I had kind of the bug of archaeology, which totally did not go well, because the problem is with archaeology, your parents always think, oh, well, you're not going to make a lot of money when you're older, so why don't you want to become a doctor or a lawyer maybe? And I said, no, I'm going to stick with archaeology. And then my parents committed the worst sin parents can commit. They went away without me. And I was really angry, because they went to a country that I had already heard about and that always fascinated me. They went to Egypt, and you can see on this picture that there's a glaring omission on that picture. It's not me. So what they did to try to work their guilt is that they brought me back tons and tons of presents. They brought me little artifacts, fake mummies, books about ancient Egypt, and from there on, I was sold. I was going to be an archaeologist / Egyptologist. So that's exactly what I ended up doing. I went to university to become an archaeologist, and I was the perfect fit for my profession, because I've always been outdoorsy, so I'm still outdoorsy now, and I get to actually work out in the field around the world, which is really, really great. And what I do as a forensic anthropologist is I mix in anthropology and archaeology with the biology side. So a lot of people are really into artifacts when they go to become an archaeologist. But in my case, I really wanted to know the history of the people who lived back in those times, because I thought it was a much more intimate history. Somebody like me, how did they feel? What did they do when back in 3,000 years before now? What did they do? How did they live? What disease affected them? That really was what was interesting me. So nowadays, of course, I still go out in the world and look at human remains. And one of those sites in which I look at human remains is in the fabled city of Ur. Now, who knows where Ur is? Well, this map will tell you, right? It's a place where you really don't want to go quite yet on vacation. It's southern Iraq, and even though you shouldn't be going there, archaeologists are allowed to go under certain circumstances, and we are allowed to dig out for bones. And here is one of those remains from Ur. So, who can tell me what this is? Yes? It's a human skull, absolutely. I recognize you. You were in my program yesterday. All right. So yes, it is a human skull. How old do you think this human skull is? Go ahead. Maybe 1,000 years. 100,000 years over there. Ooh, 500 AD. We're getting even more specialized there. Well, very good. Well, actually, this skull is 3,000 years old. I know, right? Pretty good looking still for 3,000 years old, don't you think? I mean, not bad, right? So this skull tells me a lot about the identity of a person, and I can tell whether it's a male or a female, and I'm gonna teach you after the show how to be able to identify a person when you just have this to go on with, all right? So another site where I work is, of course, Egypt. And Egypt is west of Iraq, but it doesn't take me that much time to get from Iraq to Egypt. And what is Egypt famous for? Pyramids, yes, and what else? Sphinx, yes, and mummies, absolutely, right? So some of you have probably gone to the museum. Here's one of those very famous, beautiful, beautiful mummies. What are mummies? Yes. They're human remains wrapped up in linen tissues. And you wanted to say? They're dead people, right? That's very important. Yes, they are dead people preserved for many, many, many years. So the Egyptians wanted to preserve their dead people because they really wanted to preserve those they loved, including their pets and every object that they had when they were alive. So what we're going to do now, I'm going to need 3 volunteers who are not afraid to handle mummification. Coming up. And we're going to mummify a steak for eternity. All right, so how are you doing? Good. All right, so these are my apprentice embalmers, those who were the people who were mummifying the bodies. So the first step is going to be, so you're going to take the salt right there, and it's going to be pouring salt on the steak. So make sure you cover the steak with the salt really well. So every single part. It's not as easy as it looks to embalm, right? So why do you think the salt is necessary? Yeah? It dehydrates, absolutely. So the salt is actually going to suck up the moisture, and moisture is really bad because it decomposes very quickly the meat. It starts stinking, it's goo, it's gross. Right, with this, it's going to actually make the meat very, very, very dry. All right, well done. Gosh, he's a great embalmer. He's been doing that before. That's a little concerning. All right. That's good. Excellent. Just making sure every single piece is covered. Well done. So you can, I think there's a paper towel over there. All right, so the second step, that will be for you. And the second step, now you have your dried piece of meat, or it's going to dry up. But the problem with dry meat is that it becomes very brittle. So you need something to cover the meat so that it keeps together, right? So the body doesn't fall apart and doesn't become brittle. And that envelope is actually a sticky envelope made of honey. So go ahead and use the honey. You can just pour the honey over the salt. That's going to be fun. Very nice. And so the honey has another property. Honey, if you've ever had a sore throat, what would your parents give you? Yeah? Yeah, tea with honey, right? So why do you think the tea makes you feel better with the honey? It's actually an antiseptic. So it kills germs. So the honey serves 2 purposes. It will kill the germs, and it will preserve the brittle meat. All right. You've made my job really nice and gooey now. Very well done. So when this honey eventually dries up, this meat is going to be nice and preserved. Try not to replicate this at home, because I don't think your parents will like that. Although maybe you can make a nice barbecue sauce afterwards, but... All right, so the next step is a step that I'm going to do myself, which is the most famous step. It's the mummy bandage. Who has been dressed as a mummy at Halloween? Come on, with toilet paper. Right? So the mummy bandage is where you wrap up the mummy into the famous bandages, right? So you wrap it up all around like so. Here, I'm just going to wrap it up by cutting it little by little. In fact, the ancient Egyptian would not wrap up the body by just turning it around and around and around. They would do exactly this. They would cut little pieces and put the wrapping very tightly around the body. And what they would do is write little prayers on these wrappings so that the person would make it more easily into the afterlife, so that any kind of blocks to the afterlife, and especially to heaven, would be transgressed thanks to the prayers. And they would also put little amulets so that those amulets would also protect the body, which is, of course, something that the tomb robbers knew very well. That's why you never find mummies with their wrapping, because the tomb robbers knew where to try to find the precious amulets, right? So, do you think that we are done now? We have our nice bandages. Are we done? No, we're not, because actually you could see just as I was doing that, the bandages they come off, right? So you need to also keep the bandages down and nicely coated. And this is the job of our third embalmer, who's actually going to take sap, go ahead, and she's going to pour the sap over the bandages. Go right ahead. And the sap, yes. Wow, she's enthusiastic. The sap, once the sap is actually nice and tight and actually dry, is going to form a coat on the table as well, and will keep the bandages in place for eternity. Thank you very much. That was the best mummification ever done since ancient Egypt. Well done. Thank you so much. All right. So in about 3,000 years, when archaeologists dig up New York, this is what the steak is going to be looking like. Beef jerky. You'll never eat beef jerky the same way ever again, are you? All right. So my job's really cool because I get to solve mystery on a daily basis. Not only do I get to solve mysteries of mummies, and actually performing mummification is important because it tells us as scientists what the steps are and where we can look for DNA. Each of those steps may actually damage the DNA inside the mummies, so it's important to know what each of those steps actually are. And I get to solve mysteries by looking at bones, and I'll show you how we do that later on. And all in all, it's very important that you know that you shouldn't actually get stuck into one part of a field. So I'm an anthropologist who's mixed biology with my knowledge of archaeology to solve mystery. It's very important that you keep your mind open to all the possibilities of all the fields out there. Thank you very much.
All right, who's ready for some Arby's? Yeah, let's all go head over. Get some, that looks delicious. All right, well, terrific. Well, that's pretty exciting. So you've gotten to see that there's all sorts of areas in science that you can pick a job for and go and use your skills. All right, so how's this for a job? How many of you would be interested in a job where toy companies and appliance companies all over the country send you free stuff all year long? How would you like that? Yeah, that'd be kind of fun, wouldn't it? Believe it or not, there is a job where that is the case. But you do have a little work to do. You need to test these things and make sure that they're in good shape. So please welcome the Chief Technologist for Good Housekeeping magazine, Rachel Rothman.
Hi, everyone. How are you guys doing? So as Science Bob was saying, I think I have the coolest job of just about anyone. As Chief Technologist, I get to test all the latest and greatest products out there, whether it's beauty products, whether it's the clothing I'm wearing, whether it's kitchen appliances and toys, my personal favorite. I get to test that every single day. And I work with an awesome team of scientists and chemists and biologists. I have mechanical engineers I work with, electrical engineers. So as they were all saying, there are all these really awesome things that you can do as a scientist. But growing up, I didn't really know that this was a possibility. I have 3 siblings. We're all extremely close, as you guys can see from the picture. We were always playing sports together. My father's in the audience. He's over there. He coached us all. So I think they have a photo of us playing sports. Of me playing sports. So I played lacrosse, I played soccer. We were all engaged in a lot of different things. And even to this day, I'm still super close with my family, and we're a really tight-knit group. But we all had different interests growing up, and my interest was always in science and mathematics. So when it came time to go to college, I knew that I wanted to study that. So I studied mechanical engineering. But even when I was studying that, I had no idea such a cool job existed. I just knew I really liked taking things apart and putting it back together again. Anyone in the audience like that? Anyone like taking things apart, putting it back together? I see some hands out there. I think we have some budding engineers. I know they called dibs on some of you guys for chemists before. That sounds like an engineer to me. So I went to school, I studied mechanical engineering, and very fortunately, I had an advisor tell me there's this awesome job where they want a mechanical engineer to test products. And the rest is kind of history. So what is an engineer? You guys can shout out some things. What are some words that come to mind? Science, problems. Yeah, I'm hearing a lot of the right things about it. Yes, so an engineer is actually someone who takes science and gets to apply it to solve real-world problems. Whether it's the engineers at Google and they're developing, these phenomenal search engines that basically help us do a lot of different things. The chairs that you're sitting in, different engineers help design these. Engineers get to do really awesome things. And my job is finding products, looking at them, and then finding out which ones are the best, which ones are going to do really well, and which ones that you should go out and buy. Because whether you're spending $5, you're spending $50, you spend $50,000, we want to make sure the product you're getting is going to perform well. So I figured I would call up some volunteers to help me actually look at some of the things I looked at in the lab, and you guys are going to help me judge whether or not you think it should pass or fail our test. That sound good? Yeah, you guys ready? All right. I have my volunteers coming on up. I'm going to need 5 volunteers. We're going to get started with the first one. So, if you can hold this out to the audience, open it up. What does it look like? What do you think it is? It is an Elsa costume. So, what do you think the scientists in my lab looked at when we're looking at this costume? What's something you think they may do? So they may watch the movie. That wouldn't be included in this particular test. Maybe when we're testing TVs. But audience, what do you guys think? What do you think are some of the things they may do? Who said light it on fire? I heard a light it on fire. That's actually one of the tests that we do. It's flammability testing. I get to set things on fire as part of my job. How cool. I get to drop things. I get to set it on fire. We get to do all sorts of tests. So some of the things we do is look at the durability, but then we also do a test in which we set these samples on fire. So this particular costume, my volunteer, do you think that it would pass or fail the flammability test? Audience, what do you think? If you think it passed, raise your hand. If you think it failed, scream fail. Okay, majority of you said fail, and you are correct. This failed our test. So unfortunately, this costume, the samples that we tested, went up in flames in less than 3.5 seconds. So it is definitely a dangerous costume. Thank you very much. I appreciate it. All right, my next volunteers. If you guys, you may have to take your hat off for this one. If you guys could try to figure out how you would use this product first. All right, I'm going to give you a hint. You're going to put it over your head. It's going to go on your head. If you get uncomfortable, you can take it off, but try to put it over your head. All right, you want to make sure you have the hole in the front so we can breathe. So turn it around this way. There we go. All right. Audience, what do we think that they're wearing right now? Oh, sleep everywhere. Who said that? I heard it. So these are actually called ostrich pillows. So I don't know if you guys know about ostriches and the way they sleep, but they can actually sleep standing up. So they can just be standing there, sometimes even with their eyes open, and they could be sleeping and you wouldn't even know it. So as humans, we can't exactly do that, but sometimes you want to fall asleep whether you're on the train, whether you're on a plane, you're transiting to work. Do you guys want to try, maybe lean down on your shoulder? Do you want to lie down on the ground, see if you can get comfortable with it? Oh, yeah. See if you lie down. How does that feel? What do we think? It feels okay. Okay, you guys can stand up. All right, so what are some of the things you think the fiber scientists are actually the people who look at this in our lab? What do you think some of the things they look at are? You can take it off your head so we can hear you. What do you think? So this one you can do that as well, but we're actually looking at like the construction of it, so how durable they are, how soft they are. But even if in the lab it does really well, if we have people then try it and they don't like it, it's not really a great product. So audience, again, if you think it passed, raise your hand. If you think it failed, scream fail. This one failed as well. So in the lab it did okay, but again, it's kind of a silly thing. I don't know if you guys would wear it. I would never want to be wearing this in public. So it wound up failing our tests. All right. I think it's pretty obvious what these are. If I get my volunteers, I need you guys to start lifting some weights. Start doing some reps for me. Keep going. Oh, yeah. Work it out. You don't have to go to the gym later. This is going to be your workout for the day. I get out of working out right now. All right. Keep going. All right. So what do you think we test in the lab for this? Keep going. What do you think? What are some of the things you may test if it comes to weights? Audience, what do you guys think? I heard balance, definitely. Okay, so that's actually, you know what, audience, stand on up. I need you to stand up. Everyone in the audience, get up. I want you all in your right hand, picture you have a 20-pound weight in your right hand. I'm not lifting it. In your left hand, pretend you have like a 2-pound weight, a 2-pound dumbbell. So in the right hand, we're gonna squeeze it up. It's so hard. And now in the left hand, the 2-pound one. It's like, oh, this is easy. Now in the right hand, the 20-pound. Left hand, 2 pounds. All right, you guys starting to know it? So what do you think some of the things we may do is? Someone had said it before. We're actually looking at the weights. Thank you guys. You guys can sit down. You guys are awesome. Thank you. So with the weights, what we're looking at is, are they actually the same weight? So we have mechanical engineers, and they're looking at it on precision scales to see whether or not they're going to weigh the same amount. All right, so audience, putting it out to you. Did it pass, hand up, or scream fail? All right, so we got mixed answers in here. So we looked at dozens of sets, and what we found is some of them are closer in weight than others, but no two were exactly, accurate in what they weighed. So thank you guys. You guys don't need to keep on lifting anymore. Are you guys tired? But a good trick is, so in general, they were pretty okay, but some of them were off by as much as 15 to 20% difference between the two weights. So if you're lifting two different sets of weights and they weigh a different amount, in the end, you may get more bulky on one side or feel it a little bit more. So we recommend you just put a dot on one of them, so each time you can alternate the different sides. And then we also look at things like the durability and the construction of these. Thank you. Can I get a round of applause for my volunteers? Before you guys go off, you guys want a piece of candy? Anyone? No, don't take it. It's not candy. Has anyone seen these? These are laundry detergent packets. So a while ago, these came out on the market, and they were an ingenious solution to an everyday problem. So when you're going to the laundry, you may have these really big, cans of it, and they may be spilling everywhere. So when these came out, they were really convenient, but kids were eating them, so it became really dangerous. So the government actually came out with more recent regulations around it so that the packets are harder to open and it has a bittering agent with it. So with that, unfortunately, no real candy, but you guys can take a seat down, and thank you guys, audience, for them. So those are some of the things that we've recently looked at in the lab, but I figured you guys can actually come and participate and help me do some of the toy testing that we do in the lab. So I think we already have a few volunteers that are going to come up on stage, help me test out some of the recent toys we looked at. They've been pre-warned. They may get a little bit messy during this. So if my first two volunteers can take a seat right here. All right. Have you seen this game before? Yes? What is this game called?
Pie Face.
It is called Pie Face. Oh, thank you very much. You may get a little messy, so we're giving you some aprons to put on and some goggles. So some of the things that we look at, and if you don't mind, while I'm talking, if you can put as much whipped cream as you can physically fit on top of here would be fantastic. So in the lab, we'll look at toys. And the first thing we do whenever we get a new toy is to check for safety. So the government, just like that, put it on an angle and get as much as you can on there. So we always look at the safety of it. All right, I think that's good. So we're always looking at the safety of things. And the government actually has tests that we can do to make sure that they're conforming to it, but then we do our own tests in lab. So one of the things we may look at with this, it's a mechanical toy, is the crank. Is it going to keep on working when we're using it? So different things like that. So you guys are going to take a turn with this game. So once we check and make sure it's safe, we need to make sure it's fun, right? Who wants a toy if it's not any fun? So if you want to go first, if you don't mind, you want to spin it? Let's see what we get. Wait, hands a little on you. You got 3. So you got to crank it 3 times. And guys, I'm going to need you to count with me. And I warn you, at any time, if you haven't seen this game, the pie can go in the face. So at any point, randomly, during the cranking, it could go in the face. So you got to make sure you line your face up right in there. All right, audience, go. 1, 2, 3. Pie in the face. All right, if you want to keep on going, you guys are going to play until you get to the number 10, and I'm going to take my 2 other volunteers. Can I get you guys to come over here? And you can grab this one. So we also look at ride-on toys. This is another fun test that we do in the lab. So again, we have already vetted them for safety by the time we ever have kids come in to look for that fun factor. So I'm going to let you guys try this one for the first time on your own, and we're going to do it as like a trial run, and then we're going to have a race going in the other direction. So can I have you guys line up straight in this direction? Let's go this way a little bit more. Do you guys mind this way? Good job. Who's seen these before, the space scooters? Anyone? Audience, scream out if you've seen them. All right, so not too many. So we get in a lot of toys and gadgets and everything before they even hit the market. So we're testing them, so in the end, you'll know whether or not they're good enough to get. So with this, if you want, you can just do it like a normal scooter. If not, you're going to put your back foot on it, and it's going to kind of be a pump and go mechanism, okay? So you guys can give it a whirl. You can do it a little bit slower the first time. Try it out. Pump in the back, or you can do the normal scooter. All right, that was good enough. We're going to try it. Ooh! Good. All right, we're going to line up one more time. This time we're going to go this way. Do you guys want to try the other way or no? You can keep doing it that way if you'd rather. If you put one foot on here and then one back there, and it's literally like a pump back and forth. It's kind of difficult. Yeah, it took me a while too, and with this, it's not going to be, so I can't stay balanced anymore. You guys can just do it the normal scooter way, all right? And you guys are going to try to tag our partner in the back, okay? On the count of 3. 1, 2, 3. Time! All right, let's hear it for both of our volunteers. So what'd you guys think? Afterwards, what'd you guys think? Was it fun? Is it something you would do again? Way too high, okay. So some things we may want to look at are age requirements, making sure it's for the right size person. So a lot of these different things we'll look at in the lab. So I have one more toy we're going to test out. You guys can head on down if you guys want to. You can head on down, thank you. All right, so one of the things when we're doing toy testing in the lab, it's really hard to get kids to stop playing with toys, unless you give them another toy. So if you guys want to stand up with these 2, come on to the center of the stage. You can leave them on or take them off, it's your choice. There you go, you can leave it on. How many times did you guys get pied? Only once? How many times? 5 times? So, what did you think? Did you like it? It's fun watching your friend get pied, right? I'm going to have to ask you where you got this shirt afterwards. I really love this shirt. So another one of the things that we look at, these are called air poppers. So with these, we were testing whether or not they're actually going to be able to project and how fun they are and things like that, okay? So do you guys want to come over here and you can try to pop them into the audience? All right, so what do you think? It works? Do we like it? Kind of works? You liked it though? So maybe,
Don't
so
worry.
depending. Okay, thank you guys so much. I really appreciate it. You guys can take a walk off the stage. You can leave it right here. Thank you. So basically, you guys got to see what I do, and it is test all sorts of things, whether it's for safety, durability, ease of use. So in the end, we can tell you what the greatest products are out there.
Rachel, and I know you're wrapping things up, but
Yeah.
I kind of have my own product. And I was wondering if you could just do a quick little, let me know how it's going to work out.
Definitely. Sounds
Sure.
great.
So, you know those little popper things?
Yeah.
Mine are a little bit different. Bring mine out. Yeah, so, see, I didn't think one was enough of that. So this one actually shoots 100
Oh, wow.
ping pong balls at once. And I think it'll be great for kids of all ages. What you do is you load this back chamber with high flammability ethanol.
I don't think that's going to pass my safety
No, I
checks.
think it'll be
don't
fine.
know.
Then you take a high voltage spark generator and you just touch it to this little bolt. That will create a spark and that will shoot it off in a small explosion.
Maybe an adult toy.
Really?
Let's see.
So here's the thing. I wanted to demonstrate it, but it turns out you're not allowed to fire things off of a stage. Yeah. So we put them up in the balconies. If we could bring our lights up, here. So you can see we've got 2 of them over there and 2 of them over there. Before we do that, though, can we please bring all of our cool scientists out here? Come on out. Give it up for all of our amazing scientists. And we also want you to know that you can get a little bit up close and interact with them right after the show. We're going to have a couple things going on stage. We'll have a couple things going on in the back. The Staten Island Makerspace will be around so that you can check all of that out. Did you guys have a good time today? All right. So, we have a lot of rain falling from the sky, but this might be a world first of a shower of ping pong balls. What could possibly go wrong, right? We do want you to watch your step as you leave, because there might be ping pong balls on the floor. All right, are our igniters up? You guys ready? All right, we're going to do 2 volleys. Volley 1, count us down in 3, 2, 1, fire! There, we got some. All right, let's try volley 2 in 3, 2, 1, fire! There we go. All right, thanks so much for coming out. Enjoy the rest of the festival. Hope to see you next year.